Hello deities, hello Sir Miggy. I'll explain the what process of database normalization. What is database normalization? Database normalization, or just normalization or as it's commonly called, is a process used for data modeling or database creation where you organize your data and tables so it can be added and updated efficiently. It's something a person does manually as opposed to a system or a tool doing it's commonly done by database developers and database administration. It can be done by any relation database where data is stored in tables which are linked to each other. This means that normalization is in a DBMS or database management system can be done in Oracle, Microsoft SQL Server, MySQL, PostgreSQL, and any other type of database. To perform the normalization process, you start with a root idea and a data you want to store, and apply certain rules to it in order to get it to a more efficiently form. I show you how to normalize database later in this article. My normalize a database, so why would anyone want to normalize their database? Well, do we want to through this manual process of rearranging the data? There are a few reasons we would want to go through this process. Make the database more efficient, prevent the same data from being stored in more than one place, prevent updates being made to some data but not others, prevent data not being deleted when it's supposed to be, or from data being lost if it's not supposed to be called, ensure the data is accurate, reduce the storage space that a database takes up, ensure the queries on a database run as fast as possible. Normalization in the BMS is done to achieve these points. Without normalization on a database, the data can be slow, incorrect, and messy. Data anomalies. Some of these points above related to anomalies. An anomaly is where there is an issue in the data that is not meant to be there. This can happen if a database is normalized. Let's take a look at the different kinds of data anomalies that can occur that can be prevented with a normalized database. Our example will be using student database is an example in this article, which records student class and teachers information. Let's say our student database looks like this. This is the example in the box, in the table. This table keeps track of a few pieces of information: the student names, the fees of student has paid, the classes student is taking if any. This is not a normalized table and there are few issues with this. Insert anomaly. An insert anomaly happens when we try to insert a record into this table without knowing all the data we need. For example, we need to add a new student but did not know their course name. The new record would like this. The example, this table: John Smith, fees 200, fees paid 200, course name economics class economics 1, class 2, biology 1, class 3. Mao na siyang incomplete, wala pa nabot nga. I will be adding incomplete data to our table, which can cause issue when try to analyze data. Update anomaly. An update anomaly happens when we want to update data when we update some of the data but not other data. For example, let's say the class biological 1 was changed to intro to biology. You would have to carry all the columns that could have this class field in the name each one that was found. There is a risk that we miss a value which would cause issue. Idea would only update that value once in the location. Example sa update anomaly ito. Sa a delete anomaly occurs when we want to delete data from the table. We end up deleting more than what we intended. For example, let's say Susan John's quit and her records needs to be deleted from the system. We will delete her row. Si Susan, ito class 2, class 3, delete niya. But if we delete this row, we lose the record of the biology 2 class because it's not stored anywhere else. The same can be said from the medicine course. We should be able to delete one type of data or one record without saving impact in other records we don't want to delete. What are the normal forms? Process of normalization involves applying rules to a set of data. Each of these rules transforms the data to a certain structure called a normal form. There are three main normal forms that you should consider actual. There are 6 normal forms in a total, but the first 3 are the most common. Whenever the first rule is applied, the data is in first normal form, then the second rule in applied data is in second normal form. The third rule is in applied and the data is in third normal form. Fourth and fifth normal forms are then achieved from the specific rule. Alright, so there are 3 main normal forms that we're going to look at even write a post on designing database. But let's see what is involved in getting to each of normal forms in more details. What is normal form? First normal form is the way your data is represented after it has the first rule of normalization applied to it. Normalization in the BMS starts with the first rule being applied. You need to apply the first rule before applying any rules. Let's start with a sample database. In this case, we're going to use students in teacher database at school. We mentioned this earlier in this article when we spoke about normalize, but here it is again. Our example database. We have a set of data we want to capture in our database. In its how it currently looks, it's a single table called student with a lot of columns. This is the example of database with student name, fees paid, date of birth, address, subject 1, subject 2, subject 3, Subject 4, teacher's name, teacher's address, course. Everything is in one table. How can we normalize this? We can start with getting the data to first normal form. To apply this normal form database, we will look each table one by one and ask ourselves to follow it of it. Thus, the combination of columns make a unique row in a single time. To what field can be used uniquely identify the row. Let's look at the first question. Does the combination of all columns make a unique row every single time? No, there could be the same combination of data and it will represent a different row. There could be the same values for this row and it will be a separated row even though it is rare. The second question says what field can be used to uniquely identify the row. Is this the student name? No, as there could be two students with the same name. Address? No, this is not unique either. Any other field? We don't have a field that can uniquely identify the row. If there is no unique field, we need to create a new field. This is called primary key and its database term. For a field that is unique to a single row, related the complete guide to database keys. When we create the primary key, we can call it whatever we like, but it should be obvious and consistently named between tables. I prefer using the ID suffix, so I will call student's ID. This is our new table. Student. Student ID, student names, feed fees, fees paid, date of birth, address, subject 1, subject 2, subject 3, subject 4, teacher's name, teacher's address, course. Can be also represented the entity relationship diagram. The way I have written this commonly way of representing tables in text format. The table name is written and all the columns are shown in bracket with the primary key underlined. This data is now first normal form. This example is still is in one table, but in made little better by adding a unique value to it. Want to find a tool that creates the kind of diagrams. There are many tools for creating these kinds of diagrams. I've listed 76 of them as guide to data modeling along with reviews, price, and other features. So if you're looking for one to use to unlock that list, estas ang example. What is the second normal form? The rule of second normal form on database can be described as number 1, fulfill the requirements of first normal form. Number 2, each non-key attributes must be function dependent on the primary key. What does this mean? It means that first normal form rules have applied. It also means that each field that is not the primary key is determined by that primary key. So it's specific to that record. This is what functional defense means. Let's take a look at our table. Our table 3. Table. All these columns depend on this specific to the primary key. The primary key is student ID, which represents the students. Let's look each columns. Student name, yes, is dependent and primary key. A different student means a different student name. Fees paid. Yes, this is dependent on the primary key of each paid value in a single student. Date of birth. Yes, it's specific to that student. Address. Yes, specific to that student. Subject 1. No, this column is not depend on the student. More than one student can be enrolled in one subject. Subject 2 is as above, more than one subject is allowed. Sub Subject 3, no same rule as Subject 2. Subject 4, no same rules as Subject 2. Teacher name, no, the teacher name is not depend on the student. Teacher's address, no, the teacher address not dependent on the student. Course name, no, the course name is not dependent on the student. We have a mix, yes or no, here. So, field are depend on the student ID and others are not. How can they solve this? What mark as no? Let's take a look. Subject. The first the subject one column is not dependent on the student or more than one student can have a subject, and the subject is not part of the definition of the student. So we can move it to one at the new table. Subject. We've called its subject name because that's what value represent when we writing queries in this table or looking at diagrams. It's clear what subject name is instead of using subjects. Now, is this field unique? That is not necessarily two subjects called have the same name in this would cause problems in our data. So what do we do? We add primary key column just like we did for student. I'll call this subject ID to be consistent with the student ID. Subject. Subject ID is subject name. This means we have a student table and a subject table. We can do this for all for our subject columns in the student table. Removing them from the student table is so like this. This student ID, student names, fees, date, birth, address, teacher's name, teacher's address, teacher's course name. But they are in separate tables. How do we link them together? We'll cover that shortly. For now, let's keep going in our student table. Teacher. The next column we mark as no was teacher name column. The teacher is separated, the student will capture separately. This means what should move on its own table. Teacher's name. Why we should also move the teacher address this table is as its property of the teacher. I'll also rename teacher address to be just address. Teacher's name address. Just like with the subject table, The teacher name and address is not unique. Sure, it in most cases it will be, but to avoid duplication, we should add the primary key. Let's call it teacher's ID. Teacher, teacher ID, teacher name, teacher address, course. Press ko itong table natin. Course. The last column we have to look is course name column. This indicates that course that the student is currently enrolled in, while the course related to the student. The name of the course itself is not dependent on the student, so we should move it to friendly table. This is so changed to course that may depend evidently of student. The course table will look this. Now we have our tables created of columns that were in the student table. Our database so far looking this table. This is example table. How do we link these tables together? We still need to know which subject a student is taking, which course they are in, and who their teachers are. Foreign key in tables. We have separately tables capturing different species of information. We need to capture that students are taking certain courses, have teachers and subject, but the data is in different table. How can we track of this? We use concept called a foreign key. A foreign key is a column in one table that refers to the primary key in other table. It is used to link to one record to another based on its unique identifier without having to store the additional information about link record. Here are two tables so far. To link the two tables is use foreign key. We need to put primary key, the underlined column, from one table into another into the other table. Let's start with a simple one. Student taking courses. From our example scenario, as a student a student can only be enrolled in one course at a time. In course can have many students. We need either the course ID from the course table into student table, adds the student ID from the student table into the course table. But which one is it? In this situation, I ask myself a question to work out which way it goes. Does table 1 have many table 2s, or does a table 2 have many table 1s? It's if it the first, then table 1 ID goes into table 2. And if it's the second, then table 2 it goes into table 1. So if we need to substitute table 1 and table 2 for course as students, those a course have many students, or those students have many courses. Based on the rules, the first statement, first course has many students. This means that the course ID goes into students table. I've italicized it to indicate it is a foreign key, a value that links to a primary key in another table. when we actually populate our table instead of having course name in the student tables, course ID in the student table, the course name can be linked using this ID. This also means that course name is stored in one place only and can be added, removed, update without impacting the tables. I've created ano teacher. We've linked the student course. Now let's look at a teacher. How teachers related depending on the scenario. They could be related in one of few ways. A student can have one teacher that teaches, teaches them all subjects. A subject could have teacher that teaches it. A course could have teacher that teaches all subjects in a course. In our scenario, a teacher is related to a course. We need to relate these two tables using for it K. Those a teacher have many courses or those many courses have many teachers in a scenario, the first statement is true. So the teacher ID goes into the course table. This is the table. Course example table and the teacher example table. This is allow us to change the teacher's information without impacting the course of student and subject. We link the course teacher and the students table together so far. What about the subject table? Do subjects have many students or those as student have many subjects? The answer is both. How is possible? A student can be enrolled in many subjects at a time. A subject can have many students in it. How can represent that? How can how could try to put one table side in table? This is example. But if you need to do this, we restore many pieces of information in one column, possibly separated by commas. This makes it hard to maintain and is prone to errors. If you need this kind of relationship that one on that goes both ways, it called many relationship. It means that many of one record is related to many of the other record. What is the third normal form? This normal form is final stage, the most common normalized process. The rule for this is fulfill the requirements of second normal form, has no transitive functional dependence. What does even mean? What's transitive functional dependence? It means that every attribute that is not primary key not depends on the primary key in the primary key only. For example, column A determines column B determines column C. Therefore, column A determines C. This means that column A determines column B, which determines column C. This is transitive functional dependency. And it should be removed. Column C should be in a separated table. We need to check if this is the case of any our tables. Do any non-primary case depends on the something other than the primary key. No one of them. However, if look at the address with something interesting, we can see other relationship between the zip code and the city of suburb. This is common with address, and you may have noticed this is This if you have filled out any forms for a thesis online recently. Or the related zip code, postal code determines city and suburb. In this case, 56128 is South Boston and 56125 in North Boston. I just made this probably incorrect data. This is falls into the pattern we mentioned earlier. That A determines B, which determines C. Student determines zip code, which determines suburb. So how can improve this? These changes could improve the design, but if not detailed them in any of these steps, they are not required for normal form. I hope this explanation has helped you understand what normal forms are what and what normal is in the BMS. That's all. Thank you.